exponential and logarithmic equations. So for example, solve for x, log of 2x plus 3 base 5 equal 3. So take the inverse function. So 2x plus 3 equal to 5, which is our base, raised to 3. So 2x equal to 125 because 5 raised to 3 is equal to 125. Then transpose 3, so the sign will be changed, so it will become negative 3. So 2x equal to 122 because 125 minus 3 is equal to 122. So our answer is x is equal, 122 divided by 2. So our answer is x is equal to 61. Next is the graphing logarithms. So logarithmic functions are basically the inverse of exponential function. So this is our exponential functions, which is h of x equal to 2 raised to kt. So this is our exponential function that contains horizontal aspect, and our logarithmic function, which is j of x equal to log of x base 2, contains of vertical aspect. So just like this. So exponential and logarithmic functions have similar behavior, but the exponential function occupied by the quadrant 2 and quadrant 1, while the logarithmic function occupied by the quadrant 1 and quadrant 4. So the y-intercept of logarithmic function is 0 and 1, while the x-intercept of exponential function is 1 and 0. So you can see this. So next is the growth. So the formula is a equal to be raised to kt. So a represent the total population, while the be is the number of bacteria, and k is the constant, and t is the time. So number 1, at the start of an experiment, 1,400 bacteria are present in a colony. 4 hours later, the population is found to be 3,200. So the problem are: A. Determine the growth constant k. B. How many bacteria were there 2 hours after the experiment began. C. When will the population reach 5,000? So, just like this. So, A is equal to 1,400, which is the number of bacteria that are given. A raised to kt. So 3,200, which is the total population, equal to 1,400 A raised to kt. So we're going to divide 3,200 equal to 1,400 to the number of bacteria, which is 1,400. So cancel. So 3,200 divided by 1,400. So the answer is 16 all over 7 in fraction form. So A raised to kt is equal to 16 all over 7. So n A raised to kt is equal to n, 16 all over 7. So we're going to n A raised to kt. So just cancel it. And then ang nabilin is kt, which is k is the constant, and t is the time. So 4k, because our time is that are given is 4 hours, so 4k is equal to n 16 all over 7. So just copy k is equal to n 16 all over 7 divided by 4, which is our time. So our constant k is this. So next is B. So the question is, how many bacteria were there 2 hours after the experiment began? So T is equal to 2, which is our time. Then K is equal to N 16 all over 7 divided by 4, which is our K constant. So A is equal to the number of bacteria, which is 1,400. A raised to 2 because our time is 2. So times N 16 all over 7 divided by 4. So the answer is 2,116.6, or round off 2. So magiging 2,117. So using the calculator. So this is the answer. So next, problem C. So when will the population reach 5,000? So T when A is equal to 5,000, which is the total population. So 5,000 equal to 1,400 A raised to KT. So we're going to divide 5,000 to 1,400 to the number of bacteria, which is 1,400. So cancel. So 5,000 divided by 1,400. So the answer is 25 all over 7, which is in fraction form. So A raised to KT is equal to 25 all over 7. So N A raised to KT is equal to N 25 all over 7. So we're going to N A raised to KT. So we're going to cancel out. So ang nabilin is KT is equal to N 25 all over 7. So T is equal to N 25 all over 7, which is our K constant, divided by the N 25 all over 7, which is our answer. So here, divided by the K constant, which is N 16 all over 7 divided by 4. So the answer is 6 hours. So by using our calculator, so the answer is 6. So next is half-life. So the formula is K is equal to N 1 all over 2 divided by half-life. So number 2, half-life of strontium 90 is 28 years. How much of a 10G sample will remain after A 1 year, B 10 years? So B is equal to the amount of strontium percent at time T equals 0. The amount percent after time T A equal to B A raised to KT is equal to 10 A raised to KT. So the decay constant K is equal to N 1 all over 2 divided by 28. So our constant K is this. So A amount percent after 1 year. So A is equal to 10 A raised to kt, which is the given BE, is equal to 10A raised to 1, because the given is in A is 1 year. So 1 times n, 1 all over 2 divided by 28. So the answer is 9.75546, or round off to 9.76 G. So using our calculator. So in B, amount after 10 years, so A is equal to 10 A raised to kt, which is given, is equal to 10 A raised to 10, which is the given years in B, which is 10. So 10 times n, 1 all over 2 divided by 28. So the answer is 7.81 G. So 7.8.